Okay, so we have this bicycle wheel with a diameter of 64 centimeters and it's traveling at a speed of 21.6 kilometers per hour. And we need to draw a graph for this situation. The bicycle wheel picks up a stone on the ground and the stone follows the wheel around and around, and we have to draw this out for 2 seconds. So in a question like this, the first thing we notice is the units are not the same. So we need to convert the speed from kilometers to per hour to centimeters per second. So 21.6 kilometers per hour, if I multiply this by 1,000, I'll get 21600 meters per hour. So I've converted to meters, and then I'll multiply this by 100. So I'll get 2160000 centimeters per hour. Then I'll divide this by 3,600 to convert hours to seconds. If I divide by 3,600, I get 600 centimeters per second. So now the units are the same for the diameter and for the speed. The next thing I can do is I can find my radius, which is just my diameter over 2, which is just 32 centimeters. Now I know the equation for speed is distance over time. I know the speed, I can find the distance, and once I find the time, this is going to be my period. So I'm going to rearrange this for my time. So time is distance over speed. Distance is nothing but the distance of this stone going around the wheel, which is just the circumference of this circle. So this is just 2 pi r divided by the speed. The radius I know is 32 centimeters. So it's 2 pi 32 divided by the speed, which is 600. We gotta convert it and keep it in centimeters per second. So this is 2 times pi times 32 over 600 is approximately 0.335 seconds. So this is basically the time it takes for one revolution for the stone, which is basically the period of our function. Now we know that the bicycle picks up the stone on the ground. So we know that this is going to be a negative cosine wave because it starts at the minimum, which is basically at ground level. Then the stone goes all the way to the top of the tire and comes back to the bottom. So it's just a negative cosine wave. And this value here is 0.3351 period. So we need to draw this out for 2 seconds. So I'm going to draw a second period. To make these a bit thinner, I think I'm not going to fit it. I'm just going to squeeze it in a bit here just because I don't have space. So this is 0.335 times 2, just 0.67. This is approximately 1.335. Don't have space here, so I'm squeezing this in, but technically they should be equal width. I guess I'll redraw it down here. But it makes a bit more sense. So we need to keep it a bit small because there's a lot of waves. So 0.335, 0.671, 1.335, 1.67, and then 2. That's the wave drawn out for 2 seconds. And if you want to find the y values, we know the diameter is 64. So from the bottom to the top it's 64, which means that the equation of axis has to be directly in the middle. So this is just 32 y equals 32.